All right, so we have a new example, and I want to do this new example a couple different ways. I want to show you why this is in fact a geometric series, and then we'll also do the computations with the computer so you can see the similarities. Okay, so the situation that we're going to look at is you're starting a job. The salary they offer you is $25,000 for the first year, but they're going to guarantee you a 5% increase for the next 19 years. So what we're trying to compute is if you stay at this job for 20 years, over the course that you're at that job, how much have you earned? Okay, so for the first year, right, how much have you earned? Well, they're going to pay you a salary of $25,000. So how much will you get the second year? Well, they're going to take that salary, right, and they're going to add 5% to it. That would be 50%. That would be nice. They're going to add 5% to that salary. Okay, so that's your original. This is how much they're increasing it. So I just want to show you guys that really there's a $25,000 in common. So you can also represent an increase by doing 1 plus 0.05. That's why there's a plus in the A equals P1 plus R over N, because you're taking your original and you're adding to it. Okay, but that's where that comes from. And then again, we can also condense this down one step further and say, well, that's $25,000 times 1.05. Okay, so $25,000, your original investment, that's that 1%, and then they're also going to add in 5%. So what would your third year look like? Okay, well, your third year is they're going to take whatever you made the second year, which is $25,000, 1.05, and they're gonna, that's your second salary, they're gonna take that and they're gonna increase it by another 5%. Okay. Original, the increase. Again, now they have this part in common, so I'm gonna take that part out. And when I do that, there's a placeholder of 1 for my first term, and then this 0.05 is left over for my second term. So what I have is I really have $25,000, 1 times 1.05 times 1.05, or $25,000, 1.05 squared. Okay, so what do you think we're going to have for our fourth year? Okay, I'm like jumping past this little piece here. So for your first year, we had $25,000. For your second year, we multiplied by 1.05. For your third year, we had $25,000 and we multiplied by 1.05 squared. So for your fourth year, you're going to have $25,000, 1.05 cubed. So if you keep going, it's going to look like this. And then we're just going to go all the way to the end here. So $25,000, 1 plus 0.05 raised to the 19th n minus 1. U1R raised to the n minus 1. So you can see that we have that geometric feel. Okay, but we don't want to just know the last term. We want to add up all the money they're going to pay us over the years. So we're actually talking about the sum formula, which is the first term, 1 minus r to the n divided by 1 minus r. So we're going to add up the 20 years of salary. First term is that $25,000 initial salary that they're offering us, right? What is r? R is this factor of 1.05. Raised to the 20th all over 1 minus 1.05. Okay, so yeah, let's just plug this in. Sum formula, $25,000, 1 minus 1.05 raised to the 20th. Out of the exponent, close your numerator, divide it by 1 minus 1.05, and we have 826,648.85. Okay, so the reason why it's geometric is because they're increasing your salary. We're multiplying by this extra 0.5 to see how much it's going up. When you consider your original plus the increase, it ends up being 1 plus 0.05. And then we just condense those to be 1.05. And we're multiplying by 1.05 every single year. So this common multiplication makes this a geometric series. We want to know the total amount, so we added up all of the years, making it a geometric series, and we had a formula for that which we plugged into. Okay, now let's kind of consider this in the lens of our calculator. Okay, so yes, it's geometric. We know how much money it's going to be using the geometric sum formula. So with my calculator, what would N be? What would the interest be? What's your present value? Is this a payment problem? Future value? And then the pay per, or periods per year. Okay, so with our calculator, so first of all, let's discuss if this is going to be a present value problem or a payment problem. Okay, the reason why this is going to be a payment problem is if you continue to work for this company, they should pay you not just the first year, but again the second year. So anytime it's recurring, which this $25,000 is recurring, it's going to be a payment. Okay, so we have $25,000. We're going to work there for 20 years. We have a 5% interest rate. Because we're using the payment, the present value is going to be 0. The increase is happening once per year. And then our job is to figure out what that present value is going to be. Okay. So we're going to compare the geometric series formula to the APPS Finances time value money solver. So we have 25, 0, 25,000, and we're trying to resolve for that. Okay, so I know that your calculator makes it negative, but look, the future value of all of that money combined, added up, cumulative, is the same value we got before, right? So this is actually what your calculator is running in the background. Okay, so finances, because we're multiplying by a percent every year, have a geometric series built into the finance operator on your calculator. You officially are smarter than your calculator. Congratulations!